The second paper is on mechanism and priority design for distributional objectives and application to improve the distribution of teachers in schools. We have three of the co-authors here with us, and I welcome Umut. We'll start. Thank you.
Thanks a lot for inviting us. And so the title is a little bit different, but this is the same paper. And so as you said, so Utku and Julian is here. So other authors are Olivier and Camille. So in this paper, so we are looking for a two-sided labor market. And so the difference from the other labor markets is basically, so there is a centralized reassignment and assignment of the workers. And this is a common in both public and private sectors. So if you would like to give examples of such markets are the doctors assigning to the hospitals, the police officers are assigned to their stations, teachers are assigned to the public schools, and you can also think about the job rotation in large corporations. Okay, so the main difference here is basically we have both new workers and the existing workers in those kind of the markets. You can think that so some teachers are new graduates, and so some teachers are currently employed in their positions and they are looking for a new job, a new position. Another difference from the well-studied centralized market is that so we have a statistical matching, so which needs to be improved. So what I say by improve, so we would like to make the position of the workers better, and we would like to also improve the set of the employees matched to each employer. Okay, so this by better, so it may come from some distributional objectives, so I will discuss it later. And despite that, so the employers have preferences here, so we give right to the existing workers to keep their positions if they cannot find a better position. So these 3 points make these markets different from the other the matching markets, centralized matching markets that have been studied in the literature. And when we look at these markets, so we can observe some distribution problems. Okay, so for example, what I mean by distribution problems, so if you look at the rural hospitals in the United States, they are having difficulties to recruiting doctors. Okay, so there are not many good doctors in the rural hospitals. And another example, and that is the motivating example of this paper, is that the experienced teachers tend to work in schools that serve more to the affluent families and high achieving students. Okay. So let me give a picture here. Okay, so two maps, so which is showing the negative correlation between the share of students in disadvantaged schools and the ratio of the teachers, the experienced teachers to the inexperienced teachers. So this is a picture from France, and so every year about 90,000 teachers are asked there for their first position or being reassigned to a new position. And as you can see on the left panel here, that so where we have more disadvantaged students, okay, coming from lower socioeconomic families, we have less experienced teachers there. And this is a problem that the policymakers would like to solve, okay? And so once you think about a possible solution here is that so we can give some kind of a salary incentives. Okay, so we can increase the salaries at the disadvantaged schools, and so we can motivate the teachers to work there. However, so in France and in other occasions, so since these are the public sector jobs, so they are using some kind of a fixed pay scheme. Okay, so they cannot change the salary based on the position. And if you look at this kind of the works, okay, so in professions that attract workers based on interesting motivation, the wage elasticities are low. Okay, so basically, so you need to increase wage a lot to have a good solution for this kind of the distribution problem. So what we are doing in this paper is basically, so we are trying to solve this problem or trying to introduce a remedy to solve this problem by using the mechanism itself. Okay, so since these markets are using a centralized assignment mechanism or reassignment mechanism, so we are trying to answer the first question: can we benefit from the mechanism itself to solve this distribution problems? If yes, how can we design this reassignment mechanism that fulfill the distribution objectives? Okay, so for example, if you think about the French case, so the distribution objective can be the following. Okay, so they may the Ministry of Education may want more experienced teachers to assign to the schools where we have more disadvantaged students. Okay. So the answer for the first question is yes. And for the second question, so we introduced two strategy proof mechanisms, so where the teachers are reporting their preferences truthfully, and that improve the welfare of the schools and the teachers at the same time. Okay, so we are not just looking for the welfare of the teachers, so we are also looking for a better distribution for the schools. And we are also achieving efficiency and stability, which are two desired features in the literature, so under both mechanisms, so under each mechanism. Okay. And so we are also using the French data that we conduct an empirical and counterfactual analysis to show that our methods can improve the distribution of the teachers in schools. So since the time is limited, so I will try to more focus on the theory part. Okay, so our mechanisms, and if time permits, I will show a few slides about our counterfactual results. Okay, so theory. So this is a two-sided market, and so we have teachers on the one side and the schools on the other side. Okay, so as I mentioned before, so the difference here is basically we have a statistical matching. So each teacher is either a new teacher or a tenured teacher. Okay, so a tenured teacher is currently working in some school, and each teacher has a type that captures his or her observable characteristics. What can they be? It can be gender, it can be the race, it can be experience. And for the specific to this paper, so we are using this type as an experience. And each teacher has preference over the schools. For the school side, each school has ranking over the types of the teachers. Okay, so remember, whenever I say type, okay, so I mean the experience level of the teachers, and those can reflect the central authority's objectives. For example, if the central authority or the Minister of Education would like to assign experienced teacher to the disadvantaged schools, then the disadvantaged schools will rank the teachers by decreasing level of their experience. Okay, so you can think about other kind of objectives. So we are translating those kind of objectives into the type ranking of the schools. Okay, and when we are looking for the school's preference over the teachers, the set of the teachers, it is based on the Lorentz domination according to type ranking. Okay, what I mean here is basically a school is better off if for each teacher's type, the number of teachers with this type or a more preferred type increases after the match. Okay. So the desired properties in this market are the statistical improvement. Okay, so remember at the beginning I mentioned that we would like to improve the assignment or the initial assignment of both teachers and the schools. Okay. And the other property is the strategy proofness. So we would like to, since we are running a centralized mechanism here, so we would like to collect information, okay, so which is basically the true preference of the teachers. So you can think that why we are not looking for the school preferences, because the school preferences are commonly known here. Okay, so they are some kind of objective of the central authority, or they are commonly known based on test or something like that. The two additional property that we are looking is the two-sided efficiency. Okay, and the fairness and the stability. So which are the very common properties they are looked after under two-sided matching markets. Unfortunately, these two properties are conflict with each other. So we introduced two different mechanisms, and both mechanisms are satisfying the statistical improvement and the strategy proofness. And the first one is satisfying the efficiency, and the second one is satisfying the stability. The first mechanism. Okay, so you can think that the main property of the efficiency in the two-sided matching markets is the Pareto efficiency. Unfortunately, Pareto efficiency and statistical improvement are conflicting with each other. So we introduce a new efficiency concept, which we call statistical improvement teacher optimality. So which requires the mechanism to be statistical improvement, and it also requires its outcome is not Pareto dominated by another statistical improvement matching for teachers. Okay. So here we are not looking for the same for the schools, because we are having some kind of impossible results based on the incentives. So here the SI teacher optimality is a stronger condition than the Pareto efficiency, which says that okay, SI teacher optimality is also a Pareto efficiency concept. Okay. Our first mechanism is based on the well-known top trading cycle mechanism, and we call it as the statistical improving cycles and chains mechanism. So if you are not familiar to this literature, top trading cycles mechanism was proposed and used in the school choice, in the kidney exchange, and in the housing markets and many other applications. However, TTC type, top trading cycle type mechanisms improve one side of the marks, namely the teachers. And it is not considering the welfare of the schools. Therefore, so we cannot directly adopt those kind of mechanisms here. In fact, so we are introducing two novelty. So a novelty here, which is the pointing cross. Okay, so our mechanism will work similar to the top trading cycle mechanism. So we are working on a directed graph, but so we need to be careful about so where the schools are pointing and where the teachers are pointing, so in order to achieve the statistical improvement. Okay, so the schools are pointing in a very intuitive way. Okay, so they would like to send out the teachers. They don't want that much. Okay, so they are pointing the less preferred type teachers first, and it goes like that. On the teacher side, so under the top trading cycle mechanism, teachers are allowed to point their best choice, but we are restricting them not to point to their best choice. Okay, so basically what we are looking is as the following. Okay, if you would like to replace a teacher with another one, okay, would it cause a statistical improvement? Okay, so if yes, then we allow the teacher to point to that school. Or if that school has a vacant position to start with, then the teacher can point to that school. Okay, and in each step, the teacher points to the best school that she is allowed to point. Okay, since I don't have enough time, okay, so I will skip the example, but so if someone is interested, I will go over it later. Okay. So when we look at the properties of this mechanism, okay, even we are not allowing teachers to point to their best choice, okay, we have restriction here. This mechanism is statistically improving teacher optimum, okay, so which means that it is Pareto efficient, okay. Moreover, it is also satisfying the strategy proofness. So which basically says that, okay, so this mechanism is a really good fit if the main objective is statistical improvement and strategy proofness, and in addition to the efficiency. Okay, so our second mechanism is targeting the stability. Okay, so basically, so we don't want to have some kind of the blocking pairs in the outcome. Okay, and in the rest of the presentation, in order to keep everything simple, so I will assume that schools do not have empty sims and that there is no new teacher, but so our results hold under that generalization. And the standard stability and statistical improvement conditions are not compatible, because you can just think that, so when we have an existing teacher, okay, so the school may prefer another teacher and would like to replace that existing teacher, but then it will be conflicting with the statistical improvement for that teacher. So what we are doing is, so we are having a new stability condition, which we call SI stability. And so we are allowing some kind of the blocking pairs to occur. And the mechanism that we are proposing is based on the teacher proposing deferred acceptance mechanism, which has been suggested for the doctor hospital matching, so which has been also suggested for the school choice and many other occasions. And here our innovation is the design of the choice rule. Okay, so how do we design the choice rule here? Is basically, so we treat each position of the school having a different order over the teachers. Okay, so this is not each position is, you can think that each position is an independent object here. And so how we are constructing that prior order or the order over the teachers is basically we first distribute the statistical employees to individual positions. Then for each individual position, the statistical occupying teacher that we distributed is ranked first. And we are only allowing the teachers who have weekly better type than that statistical occupying teacher to be accepted. Okay.
You have 1 minute.
Thank you very much. So let me wrap up. So, and we are filling these positions based one by one, considering the constructed prior to of two positions. Okay. So let me skip the examples here. And by using this choice function, so we apply the deferred acceptance algorithm and we find our desired result. And we call this mechanism as the statistical improvement deferred acceptance mechanism, which is strategy proof, and it's satisfying our stability notion. And so the way that we constructed this choice function is also achieving the highest welfare for the teachers. Okay, so let me just show one picture here. So this is our counterfactual analysis, and so you can see from this picture that when we compare our proposed mechanisms, which are the left on the left side of the picture, so it is causing an improvement for both the regions which are having less experienced teachers, so which are shown with the blue circles, and it's also causing improvement for the regions which are having the more experienced teacher. And we also compared this mechanism with the benchmark mechanisms, and so we observed that we are also achieving good features. I'm sorry for the not using the time wisely and not giving more information about our counterfactual analysis. So the papers that we have cited and the related papers are shown in red here. And let me conclude. So we are looking for a two-sided market here, and so where we would like to achieve some kind of a distribution objectives, and so we are embedding this distribution objective as the preference of the multi-unit demand side here, and we are achieving those distribution objectives. And so in addition to that, we are also achieving the efficiency for TTC type mechanism, and we are also achieving the stability for the DA type mechanism. And so I have just talked about the teacher assignment. So these mechanisms can be applied to not just for the teacher assignment market or the reassignment market. So we can apply this to other markets. Thank you.
There is one question from Irene asking about whether you have tried using priority design in this practice, and if you did, and how you did it. Yeah, she's asking whether you use priority design in the work.
Thank you very much. So this is a project which is related with Julian Oliver's and Camille's project, so which is basically on the teacher assignment. And I know that, so Julian may answer this much better than me, but so I know that they have been closely working with the Ministry of Education in France. And so their initial paper was not looking for this kind of the distribution objective. So they are looking for two-sided efficiency, so which is related, but I'm sure that they are also thinking or talking about with the Ministry of Education about this kind of the improvement. So in addition to that, so we are also contacting with the school districts, so in order to increase the diversity, so by using similar methods, and we are in the middle of the talks right now. Thank you very much.